Hey guys, let's talk about comparing populations. So I'm actually going to skip straight to slide 3 because I don't really need to talk about slide 2. So it's showing us this little table here. When we're comparing populations, we're talking about of two different sets of data, and we want to really make sure we know the most appropriate measures to use. So if both sets of data are symmetrical, you're going to use the mean as your measure of center and the MAD as your measure of variation. And then if neither set is symmetric or only one is symmetric, then you're going to use the median and the interquartile range. The reason we're going to do that is if it's not symmetrical, that means there's probably some sort of outlier or the data is skewed a little bit one way or the other. So that mean is not the best, most accurate way to look at the measure of center, so we go with the median. Over here in this table though, since we're looking at dot plots and box plots, I just want to make sure we all know what we can find where. So the interquartile range we can find in a box plot and we can find in a dot plot. The mean we cannot find in a box plot though, because it doesn't give us all the specific data, but we can in a dot plot. MAD, since we can't find the mean in a box plot, we can't find the MAD, but we could in a dot plot. And finally, the median we can find in a box plot and in a dot plot. So really the reason I'm showing you this and why this is important is right here. We cannot find the mean or MAD in a box plot. So even if both box plots happen to be symmetrical, we're still going to use the median and the IQR just because that's the only way that we really can compare them. Okay, so here are two box plots. And they're not symmetrical, but they're also box plots, so it doesn't matter. We're going to use our median and our IQR. So our median, remember, is the middle of your box. So for the math class, right here, is at 10. For a science class, it's right here at 20. And then your IQR, remember your interquartile range is the range of the box. So from here to here. So we're going to do 20 minus 5 for math. And that will give us 15. So 15 is our IQR for math. And then for science, we have from here to here, so 25 minus 15, which gives us 10 for our IQR for science class. So there's lots of different inferences you could draw from this. You could talk about how the overall range is equivalent. But I would really talk about how, like here, I love how these two match up, and you can see that 50% of the science classes write at least 20 blogs, but only 25% of math classes write 20 or more blogs. So something like that, talking about how the science classes tend to write more blogs, is a really good inference to make from this. Okay, these two dot plots, I can see that they are symmetrical, right? This one is symmetrical with itself. This one is also symmetrical. They happen to be the exact same data, which is kind of nice. And since they're both symmetrical, we are going to use the mean and the MAD. So let's start with Springfield. For Springfield, remember each of these dots is over these numbers. Down here, we're using this number line down at the bottom. So you're going to add it all up and divide by how many there are. When I add all of these numbers up for Springfield, I get 1,053, and then divide by how many there are, which there are 13 dots. And when I do that, I get 81 for my mean. Okay. And then to find the MAD, I'm going to see how far away each dot is from that mean. So I'm just going to write it up here on the graph just to make it a little easier for me to tell. So from 81, this is 3 spots away, 2, 1, 0, 1, 2, and 3. And then that way I can, instead of listing all of the data pieces out, I can kind of see it would be 3, 2, 2, 1, 1, 0, 0, 0, right? Go ahead and add those new numbers up. And I get 18 divided by the 13 dots that there were. And let's go ahead and round this to the nearest tenth. So I divide, I get a really long number, but when I simplify it or round it, I get 1.4 for our MAD. Okay, now let's do Lake City. So when I add those dots all up, I get 1,092 divided by the 13 dots that there are, and that gives me 84. Okay, again, I'm going to look back over here, and I can see that, let's see, from 84, this is 3 away, 2 away, 1, 0, 1, 2, and 3 again, just like on the other set. So when I add those all up, that's 18 divided by the 13, again, round to the 10th, I get 1.4 again. So let's talk about why that is. So notice the means are different, and they're actually 3 different, which really, if you look at this data, makes perfect sense. This first dot is kind of shifted over 1, 2, 3 spots in the second graph. So it's the exact same set of data, they just shifted it over 3 spots. So that's why our mean is just a little higher, 3 spots higher in Lake City. But the MADs are identical because, again, this is exactly the same picture of data, just shifted over on the graph. So of course the MAD, how much it's spread out, is going to be identical. I would talk about things like that when I'm making my inference down here at the bottom. Okay, let's go ahead to the next one. So here we have 2 box plots. So we have to use our median and our IQR. So median again is down the center. So I'm getting 70 for Treetop and 50 for Zip Adventures. IQR is the box, so I have 80 minus 50, gives me 30 for Treetop. And for Zip Adventures, I get 60 minus 40, which gives me 20. Okay, which company has the greater number of daily participants? You can tell that Treetop Tours does. So Treetop does, because here these line up 75% of people are here above 50 a day, or 75% of the days are above 50 people a day, but only 50% of the days are. For Zip Adventures, also you can just see how much higher they get, up to 100 for Treetop, and nowhere close to that with Zip Adventures. Okay, so here I can see Jada is symmetrical, but Angel is not. She's a little bit all over the place. So since only one of the 2 are symmetrical, we have to go with our median and our IQR. Okay, median is pretty easy. Remember, you can list them out and kind of cross them off till you get to the center. So I'm going to just do it straight from the dot plot up here. Cross that off, that off, that and that, that and that, that and that. I get these 2 in the middle. They're both at 8. So our IQR there, or sorry, our median there is 8. Okay. And I'm going to do the same thing real quick for Angel. So cross, 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 cross. And again, I've got 2 8s here in the middle. So both of their medians are 8. To find the IQR though, this is a little different. So we do have to list out the data. It's going to be a lot easier if you do have it listed out. So I have, let's see, I have 6, 7, 7, 8, 8, 8, 8, 9, 9, 10. To find our IQR, we have to start with that median. So I'm going to go back to that median, which was in between these 2. And then we actually need to find the median of each side of that data. So to the right and to the left. So here and here. And then that 9 and 7 is what I'm going to subtract to find my IQR, because those would be like where the outside of your box would be. So that gives me a 2. Same thing for Angel's data, except it's a little different. So 5, 7, 8, 8, 8, 8, 9, 10, 11, 11. Start by finding that median, which was in between these 2 8s. And then find the median again, right here, and on the other side, right here. So I'm getting 10 minus 8, which is also 2. So who typically works the greater number of hours in a week? It's interesting because it looks like they should be identical. The median is 8 for both of them. The IQR is 2 for both of them. However, when you actually look, you can see that Angel has more days that are higher than 8 than Jada does. So Angel works more.